Lesson 11.1, Task 3. Write an inverse variation equation. If you know that two quantities, x and y, vary inversely, you can use one pair of data values, x and y, to find the constant of variation a and write an equation y equals a over x, relating x and y. You can then use the equation to determine other pairs of data values. The quantities x and y vary inversely, and y equals 12 when x equals 3. Write an equation relating x and y, then find the value of y when x is 42, and the value of x when y is 4. Alright, so they give us some information. So we're going to start with our general equation here, y equals a over x, and then we're going to substitute the values 12 and 3 just to get started. So y is 12, we plug that in here, and x is 3. When we do that, we're left with only one variable, our a, so we can multiply both sides by 3 and solve for a. So when we're given an x and y, we can solve for a. So y equals 36 over x is our equation when we use these values to relate x and y. So it says write an equation relating x and y. Alright, so then it says find the value of y when x is 42. So our equation, y equals 36 over x, all you have to do is substitute in the 42 and reduce the fraction, becomes y equals 6 over 7. Then it says find the value of x when y is 4. Alright, so same kind of thing. We go back to the y equals 36 over x. That's our equation. And this time we're going to put y equals 4. So you can multiply both sides by x. You always multiply by what's in the denominator. So multiply both sides by x, then divide by 4 to get x equals 9. Alright, so it says, what is always true about the product of x and y if y varies inversely with x? Well, if you look at the equation here, y equals a over x. So if you're talking about the product of x and y, when you multiply both sides by x, x times y equals a. So you're going to find that it's the constant of variation. So it says the product of x and y equals y. The product of x and y equals the constant of variation. So that's what it would be, the a. The product of x and y equals x, no, and the product of x and y equals 1. All right, so if these vary inversely, then the product of x and y will equal a, or the constant of variation. All right, how could you use this fact to find the constant of variation in task 3? All right, so since y equals 12, when x equals 3, the constant of variation of a equals x times y, or 36. And if you look back up here, that was just our given information again. All right, they gave us y is 12 and x is 3. That was what we started with in the very beginning. All right, how would this equation relate x and y in task 3 change if y equals 12 when x equals 3, but y varies directly with x rather than inversely with x? All right, so that would be, the equation would change. Because when you plug this in and we found y is 4, so now it's going to be 4 x. So y will equal 4x. And if you put a 3 in here, 3 times 4 equals 12. So it still will work out. All right, that's all for task 3. If you have any questions, please let me know. 11.1, task 4. Check data for inverse variation. You can rewrite an inverse variation equation, y equals a over x, as x times y equals a. So a set of data pairs x and y shows inverse variation if the products x, y are constant or approximately constant. Okay? All right, number 4. When water falls from a spout, the speed of the water increases as it falls, and the column of water becomes narrower. For the water column shown, the water speed v and the column's cross-sectional area A are given at 4 different locations along the column. Determine whether cross-sectional areas vary inversely with the water speed. If so, write an equation that models this relationship and find the cross-sectional area when the water speed is 5 feet per second. Alright, so the first thing we're going to do is find out if it varies inversely. Alright, so the faucet opening is 1 inch in diameter right here, and it shows that the speed or velocity is 3 feet per second, and the area of the cross section is 0.79 inches squared. Okay, so that's at the top, and then it shows you 3 more as you go down the water, as the water travels down to this pan here. So it gives you the V and the A for each one of these, and it gives you the distance from the faucet or the opening. Alright, so it says find the product V times A for each data pair. Alright, so it gives us V, it gives us A, so all we have to do is 3 times 0.79. And you get 2.37, and then we get approximately 2.37. Here we get 2.38, and the last one here is approximately 2.35. So these are not all exactly equal, but they are approximate. They're very close. And you can see it does say if they are equal or approximately equal. Here it is. If the products x, y are constant or approximately constant. And with these being very close to being the same thing, those are approximately constant. Alright, so the products are approximately constant, so the water's column's cross-sectional areas varies inversely with the water speed. So it says write an equation that models the relationship between V and A. So based on the product above, a good approximation for the constant of variation is 2.4. So all of these can be rounded to 2.4. So if we let A be 2.4 and you write an equation relating V and A, so we have V times A equals 2.4. And we know this was V and this was A, so we know that all of these are V times A equals 2.4. Then we can write this as A equals 2.4 over V. So all they did was divide both sides by V to get A equals 2.4 over V. Alright, so it says find the cross-sectional area when the water speed is 5 feet per second. Alright, so if we're looking for the cross-sectional area, we're looking for A when the speed or the velocity is 5 feet per second. So all we have to do is plug this in for V. So we're going to have 2.4 divided by 5, which is 0.48. And that would be 0.48 inches squared since we're talking about area. Alright, it says, can you write an inverse variation equation that gives the water's speed as a function of the water's column's cross-sectional area A? And the answer should be yes, because all we have to do is solve for a different variable. And it says, if so, what is the equation? Alright, so let's look at what we're given. So above we are given if I can get my pen to work here. Alright, so we are given A equals 2.4 over V, and now we want to solve for V. Okay, so all we have to do is multiply both sides by V. So we've got A times V, or V times A, it doesn't matter. Multiplication is commutative. And to solve for V, we now divide by A. So all we did was solve for a different variable. So V equals 2.4 over A. So if we look at our choices here, it says V equals 2.4 over A. That would be our correct choice. All right, the next question says, suppose that when the water hits the bottom of the container shown, the cross-sectional A of the water column is 0.18 inches squared. So that means our A value is this. What is the water speed when it hits the bottom of the container? Round your answer to the nearest tenth. All right, so all we're going to do is take this right here, okay? We're looking for the speed or the velocity, and we know V equals 2.4 divided by A. So we're going to do 2.4 divided by the cross-sectional that they give us, which is 0.18. So if you do 2, if we do 2.4 divided by 0.18, that's going to give us 13.333. All right, so this says round your answer to the nearest tenth. So 13.3 feet per second when it hits the bottom of the container. All right, that should be everything. If you have any questions, please let me know.